Good morning, students. Welcome back to chemistry online class. Students, today we are going to discuss about periodic trends in properties. First, we can see what is periodic. See, anything which repeats itself after a regular interval is called as periodic. For example, for every 29 and off days, we can see the full moon on the sky, and this occurs periodically, isn't it? Likewise, in the periodic table, most of the elements were repeated after regular interval. It is repeated with the same properties and they are grouped into columns. For example, sodium atomic number is 11, potassium, it comes under 19. Okay, after 19th element is what? Potassium, but it shows some properties of sodium, so it is repeated, isn't it? So they comes under a single group called alkali metals. So we can see now what are the properties that are shown regularly by the elements of the periodic table. First one, atomic radius. Second, ionic radius. Third, ionization energy. Fourth one, electron negativity. Fifth one, electron affinity. Now we can see one by one. First one, atomic radius. Distance between the center of its nucleus and the outermost shell containing valence electron is called as atomic radius. Okay, distance between the center of the nucleus and outermost shell containing valence electron is called as what? Atomic radius. It is like a circle. How you will find the radius of a circle? Similarly, here also, see, consider this as a lithium atom. It contains two shells. Okay, first shell contains, this is centris, this is the nucleus which contains protons and neutrons. Here it contains two electrons, here it contains one electron. So the distance between the center of the nucleus to the outermost shell containing valence electron, this distance is measured as atomic radius. This distance is measured as what? Atomic radius. But it is not possible to measure the atomic radius for an isolated atom. Directly you cannot measure the atomic radius for an isolated atom except noble gas. Except noble gas, it is not possible to measure the atomic radius for an isolated atom. You cannot measure the radius of lithium in an isolated form. So, atomic radius is referred as metallic radius or covalent radius. So atomic radius is measured in the form of metallic radius as well as covalent radius. First we can see what is metallic radius. Metallic radius means atomic radius between two adjacent metal atom. Two adjacent metal atom is called as what? Atomic radius. So how we will find two adjacent metal? Only it can be possible in solid forms, isn't it? So metallic, that is metals in solid form, that is either in crystals or in lattice, either in crystals or it in lattice. Okay, so consider, here is a diagram. Consider this is a metallic lattice made up of copper. All are repeating units of same atom, copper lattice, okay, or copper crystals. So how we will measure the radius? We know how to calculate. It's the distance between the center of the nucleus of two adjacent metal atoms. So see here, these two are also same metal, copper, copper. So we have to measure the two adjacent nuclei, the distance between two adjacent nuclei, and its internuclear distance between two metal atoms, and denoted by the letter what? R. Denoted by the letter R. See? Here, for example, we can see the atomic radius between two copper atom we have measured as 2.56 Armstrong. 2.56 Armstrong. What is Armstrong? Generally, the radius is expressed in the unit of Armstrong. Atomic radius of two copper atom is what I said? 2.56 Armstrong. So for individual atom, it is off, isn't it? You have to divide it by 2. So you get 1.28 Armstrong. You get 1.28 Armstrong. Okay. Usually the radius is measured in the unit of either Armstrong. The Armstrong and picometer. Either it is expressed in Armstrong or a picometer PM. Have you understood, students? So metallic radius means two nucleus, that is two adjacent nuclei. Atom of two adjacent nuclei. The distance between the internuclear distance between the two metal is called as metallic radius. Okay, ma'am. So after getting the value, you have to divide it by 2. So you will get the individual atomic radius. Okay, ma'am. And it is expressed in the unit of Armstrong or picometer. Now we can see what is covalent radius. It is observed in non-metallic elements. Okay, covalent radius is the atomic radius in non-metallic elements. It is defined as the half the distance between the adjacent nuclei of two covalently bonded atom of same element in a molecule. Okay, atomic radius is in non-metallic element is called as what? Covalent radius. And what is the definition for covalent radius? Means it is also the distance between two adjacent nuclei of covalently bonded. Covalent bonds you already know, isn't it? Ionic bonds by what? Transferring of electrons, where equal sharing of electrons between two atoms is called as what? Covalent bond. For the bond formation, both the atoms have to share one electrons, okay, to make the outer structure stable. So that is called as covalent bond. So like covalently bonded two atoms, atomic radii can be found out by covalent radius. Okay, so the distance between adjacent nuclei of two covalently bonded atom of same element in a molecule. So shall we see one example for covalent radius? For example, we can see H2 molecule. H2 molecule bonded by covalent bond. Hydrogen atom, hydrogen atom. The internuclear distance between two hydrogen is denoted as R, and its value is found out 0.74 Armstrong divided by 2. So we will get the individual radius of hydrogen atom as 0.37 Armstrong. Covalent radius for hydrogen is 0.37 Armstrong. Okay, ma. Likewise, we have to find out what? Covalent radius. Another one example. See here, chlorine molecule, Cl. Their atomic radius was found to be, they are covalently bonded each other. They are covalently bonded each other by sharing of one electrons. So the value is found as 1.98 and divided by 2 to get off. So you get 0.99 Armstrong, or if you are expressing in picometer, it is what? 99 PM. Okay, that is 198 picometer divided by 2 is given as 99 picometer. Okay. So the value of picometer is 10 power minus 8. So 198 when you divide it by 2 it gives 99 picometer, that is PM. Okay. Have you understood? And this is for only homonuclear elements. Homonuclear means the H same atom, Cl same atoms between the same element. We studied in the definition. It is the same element of a molecule. So H2 is a molecule, Cl2 is a H2 gas, Cl2 gas. In both we contain same, that is homonuclear elements. And how to find out non-identical atoms? For example, HCl. For example, what? HCl. See, here the calculation is done by using a method called as Shoemaker and Stevenson method. How we will calculate for non-identical atom means by Shoemaker and Stevenson, and the formula is given down, and this one you will study in a higher class. So both molecular, that is same element, homomolecular and heteromolecular covalently bonded atoms can be found out by using covalent radius. How we will find this value 0.74 Armstrong? Okay, that value is found out by a technique called as X-ray diffraction. X-ray diffraction. By the method of X-ray diffraction technique, we will found the atomic radius of two covalently bonded atoms. Two covalently bonded atoms. Have you understood, students? Okay. Then we can see how this property varies in periodic table. So if you take group wise means from top to bottom, the size of the atoms goes on increasing. The atomic radius goes on increasing. If you calculate the radius of these metals, it is goes on increasing. Why it goes on increasing? Due to increase in their atomic number. Due to increase in the atomic, see, this is the size of the lithium. Sodium size is larger than lithium. Potassium is larger than sodium, rubidium is larger, and so on. Okay, so the size of the atom or the atomic radii goes on increasing from top to bottom in the periodic table. For all the 18 groups, if we see the atomic radius, it will be goes on increasing due to the more valence shell. Due to more valence shell. Have you understood, students? See ma, here lithium with 1 cell. Lithium have only 3 electrons, where sodium 11. So 2, 8, 1. When we move on from top to down, the number of shells goes on increasing. The number of shells goes on increasing. Due to that, the atomic size also increases. The atomic radius value also goes on increases. So in the group wise, what? Atomic radius will be always in increasing order. Whereas in period, the atomic radius decreases. Atomic radius decreases. When we move from lithium to beryllium to boron and carbon, that goes on from left to right, the atomic radius decreases. Why means, see, for example, lithium, it contains how many electrons? 3, and it has how many shells only? 2 shells, isn't it? K, yeah. Beryllium contains 4. The number of electron has been increased. Am I right? And protons also increased. But the shell is remained same. Likewise, boron, see, the number of number of shell is same. Here 1, 2, 1, 2, 1, 2. But the proton value and electron values are goes on increasing. So the distance between the nuclear charge. What is that nuclear charge? Means the charge between the nuclear protons to electrons. The attractive force between the protons and electron is called as nuclear charge. See, here only 2 shells, here also 2 shells, but with more protons. So these protons, the distance between the proton is less, isn't it? So this proton attracts the electrons towards itself because there is no increase in the what? Valence shell. Only the number of electrons are added in same shell. Here with 1, here with 2, here with 3, here with 4. Okay, so the force of attraction between the nucleus and the outermost electrons are very short, and these protons pull the electrons towards itself. The nuclear charge is more. When we move from left to right, the nuclear charge goes on increasing. Hence, this nucleus attracts the electron towards itself. So, the outer shell shrinks towards the nucleus. So, as goes on from left to right, the size gets reduced. The size gets reduced because the electrons are added in the same shell. There is no addition of new valence shell. And the attraction between the nucleus and the electrons are more. Hence, it pulls the electron towards itself and the outer shell shrinks towards the nucleus. So, the size becomes reduced from left to right. Clear? Okay. The next one, ionic radii. Next one is what? Ionic radii. That is distance from the center of the nucleus of the ion. There we studied metals, non-metals. Here ions. Between the two ions. Between the ions. Okay. And the point where it influences the electron cloud. What is electron clouds? See, the electrons around the nucleus is called as what? Electron clouds. The outer shell, we will call it as valence electrons. The inner screening electrons, we will call it as what? Electron cloud. Okay. So, we know 2 types of ions are there. Cations and anions. Cations are formed by the loss of electrons. When a neutral atom without charge is called as neutral atom. When an atom lose 1 electron, when electron is removed, when it lose an electron, it gains positive charge. You know already, isn't it? These terms. Anion, when a neutral atom gain an electron, it gets what charge? Negative charge. So, cation means with positive charge, anion with a negative charge. Am I right? See here, a neutral atom, lithium, and the atomic size of lithium is what? 156 picometer. In picometer it is given, but when it is lose electron, when it lose the electron, and means from outer shell, one electron is there in the lithium, isn't it? 2,1. Now that is removed. It is given to non-metals during chemical reaction. So it is removed. So it has only how many shells now? With the 2 electrons in the outer shell. But more protons are there. More positive charge and less negative charge. So this positive charge pulls the electrons more, isn't it? So that outer shell shrinks and the size gets reduced. Okay. So usually the cation size are smaller than the parent atom. Parent atom means neutral lithium atom is called as parent atom. Due to more protons, it absorbs these 2 electrons more nearly closer to them, so that the outer shell gets shrinks towards it. So size it get reduced. The size get reduced. Similarly, fluorine. So after it losing electron, what is the radius? The distance between the nucleus and the outer shell become less. So it becomes what? 90. Okay, like that. Fluorine 69. That is, fluorine is a non-metal. It received 1 electron. Now it received an electron and it becomes what charge? Negative charge, isn't it? So that now 1 electron is added more but less protons. Okay, less positive charge, more negative charge. So the attraction between the positive to the negative will become less. It does not have the nuclear charge is not enough to pull the newly added electron towards itself. So that electron is far away from the nucleus. The distance gets what? More increased. Okay, so always the negative ions are what? The size of the negative ions are more than that of the parent atom. Okay, students, when an electron is removed from an atom, the size gets decreased. When an electron is added to an atom, the size gets increased because of this nuclear attraction, nuclear charge. When you see group wise, see it increases. Why it increases means, see metals, isn't it? The metallic characters, see if you see the group wise, this character, that is ionic radius, goes on increasing. We know that, isn't it? Due to the addition of what? Valence shells, more shells, the size is also increased. While if you see from period wise, it goes on decreases. We know that in periodic table, the metallic characters what decreases and which characters start to increases? Non-metallic characters. When we move from left to right, first metals, next to what? Non-metals. So the size goes on decreasing when we see from left to right. Okay, ma? The next one is ionization energy. Next one, ionization energy. Okay, energy required to remove an electron from the isolated gaseous atom in ground state to form cation is called as ionization energy. So what is ionization energy? Energy required to remove an electron from isolated gaseous atom in its ground state. Ground state means in neutral state, to form a cation. To form a cation is called as what? Ionization energy. See, from this diagram you can understand. See, here is a diagram. For example, hydrogen atom with 1 electron in the outer shell. So that is, this is the energy. This is to pull these electrons. Consider this as pulling. Okay, to remove this electron, this outer shell electrons, to remove this electron, the energy required to remove this electron from the valence shell. This is a valence electron, this is the valence shell. Okay, for a gaseous atom, to remove the electrons from a gaseous atom, the energy required to remove the electrons from the valence shell is called as what? Ionization energy. So energy can be also called as enthalpy. Okay, ionization energy, or we can call it as what? Ionization enthalpy. Have you understood? So the energy required to remove an atom from its valence shell for a gaseous atom, that is in ground state, that is from neutral state. An atom is neutral and you want to remove an electron from the valence shell. So how much energy we are applying for that is called as what? Ionization energy. Okay, and the amount of energy is measured, expressed in kilojoule per mole. And the ionization energy is expressed in what? Kilojoule per mole. When we see in the periodic table, in the group, the ionization energy decreases from top to bottom. If we see that, it is ionization energy decreases from top to bottom. From top to bottom, I said that it has more valence shell and the attraction between the nucleus and outermost valence shell will be less. So that it is very easy to remove the outer shell electrons from the valence shell when you see from top to bottom. Because of more valence shell, the attraction between the nucleus and outermost shell containing electron will be less. So we need to put less energy to remove what? That electron from the shell. Whereas if you see the period, ionization energy increases. We need more energy is required to remove the electron from what? The valence shell when it is in isolated state or when it is in ground state. Because the atomic size is small, isn't it? We studied from left to right, the radius is what? Goes on decreasing because no number of shells are not more, but number of electrons are more, and the attraction between the nuclear, there is nuclear charge also more, isn't it? Isn't it? Nuclear attraction is more since the atomic size is less. Outer shell and nucleus, the radius is decreased, hence the attraction also more. So it's very difficult, or we have to put more energy to remove the electrons from the outer shell or to overcome this nuclear charge. Hence, from left to right, ionization energy goes on increasing, and from top to bottom, it goes on decreasing, isn't it? It is very easy to, from potassium, if it's sodium, the amount of energy required will be less in potassium because potassium has one more shells are added. If it goes on, more valence shell will be added. So the attraction between the nucleus and the outer shell comes on decreasing. So we can easily remove the outer shell electrons. Have you understood? The next one is electron affinity. The next one is what, ma? Electron affinity. What is electron affinity? Amount of energy released when a gaseous atom gains an electron to form its anion. First, what we see ionization energy required to remove the electron. Here, when an electron is added to a neutral atom, it what? Release. There will be an energy change in that atom. Which atom is gaining that upcoming electrons, there will be an energy change. It releases some amount of energy. That is called as electron affinity. Here also the amount of energy released or the amount of energy change that occurs in that neutral atom also measured in kilojoule per mole. Okay, wow. Here you can see an example. See, consider this is an atom and it is gaining one electron. So an atom, it gain electron means it becomes what? Anion, and it is releasing some amount of energy. For example, we can consider fluorine. It is gaining an electron and it is becoming what? Anion, and it is the energy change observed here is 328 kilojoules per mole, isn't it? Kilojoules per mole. It is released, or it is given in negative. Okay. So this is an example for what? Electron affinity. What is affinity? Attraction. Always we know non-metals have more electron affinity. They are attractive. They will attract the electrons. They have more attraction towards the electrons. Okay. So noble gas, the electron affinity is 0. Why? Because they never take part in chemical reaction. They are non-reactive and they can never attract any elements towards any electron towards itself, isn't it? So always the electron affinity for noble gas is 0. A very important one-word question. The electron affinity for noble gas is 0. If you see in the table, what about this property we can see? Group wise, if you see electron affinity means it goes on decreasing, and from left to right it goes on increasing. Okay, left to right this property goes on increasing. From group wise this goes on decreasing. Okay, that is about what? Electron affinity. Have you understood? So when an electron is added to a gaseous atom in its neutral state, it gains that electron and it forms anion. We know that But at the same time, there will be energy change in that atom. It releases a certain amount of energy which is measured in kilojoule per mole. Last one is what? Electronegativity. Electronegativity. The tendency of atom to attract the shared pair of electrons is called as what? Electron negativity. Electron negativity. See, for two girls or two boys, okay, or your brother and sisters, they are fighting for a sweet. Which one is very strong? They will win that, isn't it? While fighting or anything, isn't it? Likewise, here also, the covalently bonded two atoms. Covalently bonded two atoms. So by sharing of electrons only, what bond is it formed? Covalent bond. Am I right? So both they have to share the electrons. So first they become very friendship. They share the electrons and they form a compound. When the time of breaking the bond, what happened? The shared electron goes to who? That is the main thing, isn't it? Okay. So that is called as electronegativity. The tendency. Which atom has more tendency to attract the shared pair of electron is called as what? Electron negativity. For example, we can see the hydrogen chloride formation. We know hydrogen and chlorine share one electrons and it forms a compound hydrogen chloride, sharing of electrons. Hydrogen, chlorine. Hydrogen has 1 electron. Chlorine has what? 17 electrons, 2, 8, 7. So they form a bond, covalent bond, and it forms a compound hydrogen chloride. When they break the bond, this shared electrons, how it will be? Okay. So hydrogen is the weakest one, chlorine is the strongest one. So who will win that shared electrons? The shared electrons were pulled towards the chlorine because the chlorine has more ionization energy and it has a lot of electron affinity. It has more attraction. Non-metal chlorine has more attraction towards the electron and its bond energy also more. Based on this property, chlorine will attract the shared pair of electron towards self, leaving hydrogen as a cation and chlorine become anion. So this tendency only we will call it as what? Electron negativity. Have you understood what is electron negativity? That tendency of atom to attract the shared pair of electron towards it. Not only hydrogen chloride, for most of the covalent bond, which one has highest ionization potential and electron affinity, they will attract the electron towards itself. And this property of the element is called as electron negativity. So electron negativity of an element is mainly based on bond energy, ionization potential and electron affinity. Electron affinity. See, the electron negativity can be measured by a scale called as Pauling scale. By using the Pauling scale, the scientist has measured the electronegativity for few elements. Fluorine, the electronegativity is for chlorine, bromine, iodine, hydrogen and sodium values are given. Learn this value for 1 words. And the scientist has come to an point, that is, if an element or if the bond between the two elements shows the electron negativity of the value 1.7. 1.7 means that compound has 50% ionic bond character and 50% covalent bond character. Okay, so electronegativity is measured by using a scale called as Pauling scale, and some of the values has been given here. Likewise, there has a scale, pH scale, you know, isn't it? What is the pH scale? You studied in 9th grade. What is that? Less than 7 means acid, above 7 means base, 7 means neutral. Likewise here, the value of electronegativity is 1.7 means that compound, that formed compound will show 50% ionic character and 50% covalent character. If it is less than 7, they show covalent character. Greater than 7 means it show ionic character. Okay, well? So, less than 7 means that bond between the two atoms will be highly covalent. Greater than 1.7 means the bond between two atoms are ionic. Here is an example. See, for example, how to predict the electronegativity for a compound. Sodium chloride. Sodium bonded with chlorine, isn't it? So here, the electronegativity of sodium is found to be 0.93, nearly 1. And chlorine is found to be 3.16. And what is the electronegativity? How to find? Means you have to minus the chlorine value from the sodium. So we got the value of this compound as 2.23. Am I right? So it is what? Greater than 1.7. So the bond between these two compounds are ionic. They show what character? Mostly they show what character? Ionic characters. So the character bond formation is ionic bond. Okay, if they are common combined ionic bond, the following properties they exhibited. No, their properties are shown by sodium chloride. So this is an example how to calculate the electronegativity. Now we can see in periodic table how this property differ. So electronegativity increases. If you see in group, this property decreases. If you see group wise, the electronegativity it decreases because due to the increased number of shells. The same reason only, that is the increased number of shells. Because of increased number of cells, the electronegativity of the elements that in the group will goes on that is number of shells in period. Number of shells goes on increasing in the group. So the property also goes on decreases. In group wise it goes on decreases. Whereas in period this property goes on increase due to increase in nuclear charge. Increase in nuclear charge. The attraction between the nucleus and the valence electron, the outermost shell, is more in periods, isn't it? The elements in the periods. From left to right, if we see, the nuclear charge goes on increasing. So electronegativity also goes on increasing. The group number of, due to the more increased number of shells from top to bottom, this property goes on decreases. Okay, that's we end the today's portion. Okay, students, and the homework for you. So here all are important. Okay, you have to learn for 1 word and 2 mark, and also you study here all the definitions for 5 properties. Today we studied what is that: atomic radii, ionic radii, ionization energy, electron negativity, electron affinity. For all you have to learn the definitions.